on in third period?
Good morning.
People are awaiting a regular answer.
We're waiting for an answer, and we got crazy. That's okay. That's cool. That's cool. All right, good morning. So today we're going to look at just a couple examples that are going to be using rectangles and averages. And the hope on this is because I saw some confusion in page 155 and 158, and hopefully these can address those concerns. So if you haven't gotten there yet, this is where you'll want to reference first. If you've already been there and you were stuck, hopefully this will help make it a little more clear. So let's start off with our rectangles.
That was really cool.
The
Yeah. Like
And let's draw a big old rectangle. We want to make it clear that it's a rectangle, so please make sure that you mark all the angles as right angles, because a rectangle has congruent angles. And because it's a parallelogram, excuse me, its opposite sides are congruent to each other. On 155, you're going to run into rectangles that have diagonals stuck in them. So let's go ahead and draw our diagonals. I just YOLO'd it, so they're a little crooked. Sorry.
Sorry, can you use that term again?
YOLO. I YOLO'd it.
didn't know it was a past tense for that word.
Yeah, there is. It's a verb, so you can do past tense, present tense.
Is
Past
it a verb?
perfect, I don't know.
An acronym?
It is now.
Okay.
I blame my daughter for that. Because it was raining, and I was like, okay, we got to open the trunk really fast so stuff in there doesn't wet. She's like, okay, don't worry, Mom, I'm going to YOLO it. Okay, so it's now a verb. All right, so, and then I want the measure of this angle in here. It's an acute, so please someone give me the measure of an angle somewhere between 1, and she said 79. Okay. So 79 degrees. Somewhere between 1 and 89, basically. All right, and let's start off with some properties of rectangles. So that way we can mark this diagram up. Because if you notice our objective, that's part of the thing we want to do today is be able to draw on our diagram and make it a little more useful. So the first thing that we know about rectangles is that all rectangles are also parallelograms. Just straight up. And from that we get that the diagonals bisect each other. What did bisect mean? Cuts in half. Lovely. So if you don't remember what that was, you need to underline, put a question mark, and over here on the left, answer your question mark. What you need? Paper by the computer. All right. And then from video 5.4, we get told that rectangles, not only do their diagonals bisect each other, but they are also congruent to each other. Which means that this piece, which is congruent to this piece, is also congruent to this and this. So now we have our rectangle that looks like so. And I'm going to zoom in a little bit so it's a little easier to see all my markings. Awesome. So if the question you were asked was, hey, find the measure of the red angle, what would you do?
It's equal, isn't it the same as down the 79?
Is it the same as the 79? No, it is not. And I mean, it could be, but there's no guarantee that it is. And right now, we don't have any markings that say that. We don't have any properties of rectangles that say those two angles are congruent. That diagonal bisecting one of those corner angles is a feature of a rhombus. Rectangles are not, all rectangles are not rhombuses. Some of them are, but not all of them. This one might be one of those that isn't. So how would I find the measure of this angle right in here? Subtract it from 90. Okay, so why are we subtracting 79 from 90? Because our,
Complementary?
yeah, they're complementary. These two angles added together, which we're allowed to do because of our angle addition postulate, says that it's going to equal the sum of that big one. There you go. So whatever that number is. Fantastic. What if we were asked to find the measure of this blue angle? What would I do there? Whoops. Some marker I don't need. How would I?
Thing? Or
The
no?
same thing?
What did you know that for?
What do you mean? Do the same thing or it's the same thing?
I said two-way, yeah, two.
Do.
Well, you
Okay,
can't
but
because
sup-
there's no number there.
Yeah, I don't know what that
They're
is.
congruent.
These are congruent?
And
Okay.
They're both right angled.
How do you know that these two pieces are congruent?
Well, no, I meant the,
Yeah, the 90-degree, totally congruent. But there's no guarantee that this line is coming in at the same angle as this one. So right now I have no guarantee that this is congruent to this just because I have right angles sitting there. They are congruent. You're right that they will be. But the question is,
how do we know that?
yes, how do we know? Why?
Because it's a parallelogram and then that means that the, right there, right at each other and the diagonals are congruent.
Okay, with parallelograms, these angles are congruent.
And they bisect.
The only time that the diagonal bisects those corner angles is when the parallelogram is a rhombus. I don't know if this is a rhombus. The only thing I know is that it's a rectangle. And rectangles don't have that property where the diagonal bisects the angles. So there's something else. What is the shape that I just highlighted?
Triangle.
Okay, what kind of triangle?
And equal.
Equilateral? All the sides are equal?
Oh, no, it makes
No. Isosceles, yeah. Look, Ma. An isosceles triangle. What do we know about an isosceles triangle? One more time? Yeah, the two sides are congruent. What do we know about the angles? Ladies and gentlemen, if you are with your phones, I'm going to ask you please to put those screen down. Okay. I don't think you can hear me. Put it away. Off the side. Thank you, bro. Thank you, bro. All right, so you said the sides are congruent. Do we know anything about angles? Flipping back to notes. I love it. It would have been in the third 6 weeks, I believe, maybe earlier.
Special right triangles or no?
No, because this isn't a right triangle, the
Or
one that's
after that?
highlighted. Would have been before, yeah.
It's with two congruent angles and one that's not right.
Yeah, it's two congruent angles. Which ones?
The corner ones.
Which corner? This corner, or this corner?
Back corner.
This corner.
Yes.
Okay. So we have to find a way to refer to the angles that are opposite the congruent sides.
Am I still looking or we already figured it out?
Yeah, well, you can keep looking because it should give us the name.
Of the theorem or what?
Yeah.
Well, what was the name of the notes, you know?
I don't remember. It was too long ago. I'm sorry.
Was it before reflection and rotation and all that?
No, it should have been right after. You didn't see it in there? Then it might have been a video note.
No, I don't think so.
Okay, might have been a video note. I'll give you the name here in a second. All right, so we need to find a way to name these angles here that are across from the congruent sides. If I were to turn this picture so that way it's sitting so those congruent sides are standing up, so that it looks more like what you're used to seeing an isosceles look like, this looks like it's sitting on its base. So could we call these base angles? Because they're the angles near the base? That would be a really easy way to refer to those two angles, yeah? All right, so we'll call them base angles. So the base angles are congruent. And this is given to us in the isosceles triangle theorem. There we go. All right, last question. Find the measure of the orange angle. What would I use to make that happen? What could I use to make that happen, to find the measure of the orange angle?
Well, first you have to find out which two are the congruent ones, or you already do that.
Yeah, we've already got these.
Okay.
Now I want that one. How can I do that?
You use the theorem,
Which one?
the one on
Which theorem?
the isosceles triangle theorem.
We used the isosceles triangle theorem to get that these two were congruent. And that's all that the isosceles triangle theorem says. We've got another theorem that deals with triangles that'll help us find that one. But what's the name of the theorem? Or what does it do? Maybe by knowing what it does, we can get to the name. What do you want to
Third
do?
angle theorem,
The which one?
third angle theorem.
The third angle theorem? That's if you've got two congruent triangles and you're trying to find the measure of the third angles in them. What happens if I were to add up all these angles inside the triangle?
You get one.
You get 180.
So you 79, 79, and then whatever the sum of that is, subtraction later.
Yep, so you'd end up with something that looks like this. So what's the name of this theorem? Well, what shape are you using?
Triangle.
Okay, so it's got the word triangle in it. What are you doing to the triangle?
The triangle theorem.
Yeah, it's a triangle
sum
theorem.
theorem.
Sum theorem. But what are you summing?
The angles.
The angles.
Angle measure.
Triangle angle sum theorem. We really try so hard to make these names confusing. We really do. I mean, it's not like they describe what we're talking about at all. Sarcasm. Let me make a little sign. Sarcasm sign. From Big Bang Theory. All right, that's all there is for triangle.
You mean rectangle?
Thank you, rectangle. I apparently need to drink coffee this morning. I am not making any sorts of sense.
It's only Wednesday.
Right? It's barely Wednesday. My brain's already like, let's go party. Not that I'm gonna party this weekend. I don't party. I'm not. Don't give me that face. All right, let's talk about the average formula really quick and how we can manipulate it in order to find some missing variables that are somewhere in the formula. So let's start off with what the formula is and what it says. How do you find the average of a group of numbers?
You add them all and then divide by the amount of numbers.
All right, so add up all the numbers. And I'm going to hopefully spell numbers right today. And we're going to divide it by the amount of numbers. Because the number of numbers just sounds weird. Okay, so the amount of numbers. All right, so give me some numbers. Any numbers?
5.
I heard 77, and I heard 5. All right, stop right there. Give me a second to catch up. So let's make 77 our average, and we're going to make a string of numbers. So here's 5. Give me some more numbers.
62.
62,
29.
29,
58.
and can we do some smaller?
Oh, 2.
2. Okay. All right, let's do this mess. So we're going to use our average formula to figure out the value of x. This is what we'd really like to do. All right, so my average is, let me get some color going on here. Here's my average.
3x plus 2.
It is a 3x plus 2, yes. Sorry for covering it with my ribbon. Here's one number. Here's two numbers. Three numbers. And four numbers. That has been our trip back to Sesame Street. All right, so the average, 77. I'm glad it's showing up well over there because it does not look good at all up here. So 77 equals, add up all of these. 5
34? Oh. Yeah, I think that's
plus.
39, 5.
Okay, don't think. You said add up and your brain immediately goes 5 plus this is, and it gets stuck. Stop thinking. Add them up. Just write that you are going to add them all up. You'll deal with the actual adding them all up later, but right now, just write down that, hey, dude, we are going to add them all up in a minute. Stop thinking.
You're gonna merge with the top name is.
Right? Okay, there you go. I'll put a little bar in here to make it. Blinky, blinky, blinky. Okay, there we go. And then all of that is divided by, how many numbers do I have?
4.
There we go.
But not the 74.
74?
77.
77. Yeah, no, not the 77. Because that's not what the formula says. All right, we need a recall moment. Oh my goodness, lightning bolt. Okay, got to think. Lightning bolt, lightning bolt.
Did you say last time we're gonna be home like
Yeah. Okay, I tried. It sort of looks like lightning bolt. Okay. We want to deal with fractions in an equation because that's what we have. And I'd like to take this moment to give you the mathy term that you're going to hear coming next year in Algebra 2. Fractions in an equation are called rational equations. So how do we deal with rational equations? How did we deal with fractions in an equation? Do you remember?
You would multiply.
Yeah, you'd multiply. You'd get rid of the fraction. Get rid of the fraction by multiplying. What did we multiply by?
Me, like,
What did we multiply by?
The denominator.
The denominator, which in this case is 4. Sometimes it's 2. Other times it's going to be some weird algebra barf stuff on your paper. That's okay. Whatever the denominator is. I need help with the 4 times 77. Calculator app to the rescue. Or superhero. Some of you have superheroes on your desk. Hook me up. It's got an 8 at the end. Huh?
308.
308. All right. Here, there's no multiplication to be done because I'm multiplying by 4 and dividing by 4 in the same like sequence, and so they cancel each other out, and I'm left with just the stuff up here and on top. I'm going to fix that too because it looks like an 8. There we go. Fantastic. Combine like terms. Okay, y'all go for it. I'm going to make a scribbly mess up here as to what the like terms are. So number, 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 number. Help. 5 minus 62 plus 29 plus 2. So all the circled things. 5 minus 62 plus 29 plus 2. It's going to be negative.
6 minus 62.
Negative 26.
Negative 26. All right.
And then 4x.
And then
I
4x.
put 4x minus negative.
That's fine. Either way works. It's the same thing. Hi. I forgot to give you your blue slip. Did I sign it? I may have signed it and sent it off to the front. Was there anything hanging on my door? I may have tucked it in with those thinking it was from yesterday. I am so sorry. I am so sorry. Your attendance, right? Your return to class? If it's not up there, it'd be in the front office already. Yes, sir.
So it comes out to 334 equals 4x.
So this is 334 equals 4x. Did I have stuff hanging there, but it wasn't in there?
Yes.
Okay. Then I don't have it because those are all the blue slips that I had up here. Let me finish lecture. I'm less than 2 minutes, okay? Give me a second. And then I'll look. All right, now what?
You divide by 4.
Divide by 4, all right? X equals 82.5?
83.
Okay. Well, 1 decimal place is not bad. All right. Is it 83 or is it 82.5?
83.5.
Oh, it's 83.5. Oh, goodness gracious. Yeah. Raw. 8 is totally afraid of 3 right now. Because 7, 8, 3. 8. 3, 8. I don't know. Lame joke. All right, so that's it. These are some things that can help you out on page 155 and 158. There's a little trig thing that you might need to do on page 155. That's kind of the easiest trick I can think of in the triangle section. So I urge you, go back to your notes, go back to your videos, go back to my lectures, which are on YouTube, and look at that trig again, because that could be useful to you. Thank you very much. Class is yours.